Okay, hello everyone. Welcome to a live session at Cheenta.com. Today we have Harsh Mishra with us. We are very happy to have him within our channel. Harsh is one of the best commenters on mathematical Olympiad problem solving at Cheenta's YouTube channel. So basically, in our YouTube videos, we ask for comments and solutions to problems from our students and viewers, and we would like to pick some of them up who have done a really good job in commenting, and we want to give out small rewards to them. The first thing that we would like to give Harsh for his wonderful comment is a book that we recently reprinted. It's called Inequality by Korovkin. We want to send it to him. We already got his address, so that's one thing. And the other thing is, we would love to give Harsh 1 month free access to our ISI CMI entrance program if he chooses to attend that. It's up to him, of course, but we will definitely extend the access. Again, Harsh, thank you for the wonderful solution. Tell us a little about yourself.
My name is Harsh, and I'm a student in grade 12. I live in Faridabad, Haryana, and I'm a math enthusiast.
That's great. So you're preparing for IITs, I presume? You were saying
Yes, sir.
something like that. Oh, okay. And do you do this type of Olympiad style problems in your leisure time or something like that?
Yes, sir. If I get bored with chemistry, then I do that.
Yeah, that's yeah. I have seen too many maths people now who do not like chemistry. Nothing against it, but that's how it is. So how is your preparation for the IIT JEs?
Sir, it's going fine actually. My Olympiad preparation till grade 10th has actually helped me a lot. I can
Uh,
easily think of maths problems of the IITJ.
right. Are you planning to take the IOQM this year?
Yes, sir.
Oh, that's fantastic. You can also look up the entrances of ISI and CMI. Those are really nice places to do mathematics, statistics, physics, computer science in the long run. Okay. Anyway, so let us go back to this problem that you have and that we asked you to solve. And can you tell us a little bit about this particular problem?
Yeah. So this problem tells us that we have an expression which is n to the power 4 plus 4 to the power n. And we have to actually prove that it's a composite number for all n, which is where n is a natural number for greater than equal to 2.
Right,
So if we just check for n is equal to 2, we will get
right,
that it's 16 plus 4 square is 16, which will be 32, which is obviously a composite number. And similarly for other natural numbers, values of n, we can see that we can write it as a product of more than two positive integers.
right,
So a number is called to be composite when we can factor it out into two uh, expressions. So basically
right,
our job is now reduced, that we have to factor it into something of this form where both are in multiplication.
right.
So if we begin with the official proof, we will first let that there are two cases.
Uh-huh.
The first case will be when n is an even number. So clearly, like we check for the n is equal to 2 case, when n is a even number, n
Okay,
power 4 plus 4 power n. So let n is equal to 2k. That will
okay,
be 16 into k power 4
right,
plus 4 power 2k, which is obviously divisible by 16. So it's a composite number. Now the real job is to prove this for all n which are odd.
uh-huh.
So this requires a bit of manipulation.
So
So we
you've
let
done so you have shown that when it's even, when n is even, then it will
yes,
be divisible by 16. So it's not a it has to be a composite number. So
yeah,
now you want to check for n equals to odd greater than 1. Okay.
yes sir. So we just check for n is equal to 3 for the sake of it. we get as 3 power 4 plus 4 power 3, which is 81 plus 64, which is 145, which is a composite number at as it's 5 into something.
Right.
So we will try to make it we will try to form a perfect square here, because if we form a perfect square, we know that a square minus b square is a plus b into a minus b. So we will try
Right.
to do something of that sort here.
Okay.
So here we have this, and 4 power n can be written as 2 to the power 2n.
Correct.
So if we just simplify it a bit more, we have, and now we see that we can compare it to the form a square plus b
Sorry.
square.
Wait. How can this happen? N to the power 2n is 2n to the power 2.
So sorry, it's actually 2 to the power n square. I didn't write it properly.
Okay.
It's 2 to the power n whole square,
To the power n whole square. Correct.
because
That's right.
it's 4 power n.
Right.
So to make it a perfect square, we just add 2ab, like a square plus b square plus 2ab. So we just
Okay.
add and subtract 2 into n square into 2 to the power n, and minus
Okay.
2 into n square into 2 to the power n.
Okay.
So this whole thing becomes a perfect square. We can write it as n square plus 2 to the power n whole square minus 2 into n square plus 2 to the power n. So
Mhm.
now we have this. Now, as I told in the beginning, we have to try to express it into something of the form a square minus b square. So we
Right.
need this to be a perfect square.
Correct.
Now, as the case we have taken, n is an odd number. So
Right.
this has to be a perfect square. Now we check n square is uh, already a perfect square number. So we just
Okay.
need to make 2 into 2 to the power n as a perfect square.
Correct. Right.
So we just let n is equal to 2k plus 1, like we substitute the value of n as that as it, because n is an odd number. So it
Right.
becomes 2 into 2k plus 1, which is
Uh-huh.
2 into k plus 1 whole square. So yeah,
Right.
we have uh, expressed the form a square minus b square. So we can just now factorize it as n square plus 2 to the power n whole square minus n into 2k 2 to the power k plus 1 whole square. So which
Right.
can be written as n square plus 2 to the power n minus n into 2 power k plus 1
Right.
into n square plus 2n plus 2 to the power k plus 1 into n.
Right.
So obviously any prime number cannot be represented as a product of two integers, and here
Right.
both of them are integers and none of them is equal to 1. So we have proved that n power 4 plus 4 power n is a composite number.
Excellent. Excellent. I think this is a very nice solution. And this is actually coming out from a very classical result called the Sophie Germain
Sophie Germain.
identity. Correct. And for our viewers, if you want to uh, if you want to learn more about Sophie Germain, you can go to Wikipedia or some other place. She is a fascinating mathematician, and you should definitely know about her. Another woman mathematician that I immediately remember of similar caliber, if not more, is Emily Noether. So you can check that out as well. Anyway, so Harsh, it's a pleasure having you. I just answered a few questions. I see that a student has asked, is tomato enough for CMI entrance? Well, yes, solving the entire test of problem solving, test of mathematics at 10 plus 2 level, that book is definitely going to take you almost there. But I would also add that you should try the book Challenges and Thrills of Pre College Mathematics for conceptual portions of the things. Now, there is also calculus that you have to take care of. So, for that, we suggest IA Marin's calculus in single variable. The main benchmark that you can keep in mind is 3,000 problems in a 1 year period. If you can do 3,000 problems in 1 year period, then that will really take you all the way. So these three books has more than 3,000 problems, so you can try them. Okay, and there are some people who are really commending you. For example, Khyati Arora is saying, "Amazing explanation." Indeed, I agree with Khyati. Very nice job, um, Harsh. And Harshvardhan Ahlwat is also saying something similar. Okay, so that's great. So Harsh, we will send out the book to you. Let me show you the book quickly. Not if you have not seen this book before, this is the book, and we have recently reprinted this, but this was actually published in Soviet Union about 50 years ago. So it's a fantastic introduction to inequalities. We'll send it to you, and I'll ask the admin at Chinta to uh, talk to you if you need for the access of ISI and CMI entrance program that we have for the next 1 month. Thank you, Harsh, for joining in today. And
Thank
for
you
the
very much, sir.
viewers, yeah, for the viewers, if you want to be present in Chinta's YouTube channel, talk to the thousands of people who are subscribed to our channel. You are welcome to join us. Just make sure you are commenting and solving the problems that we give out regularly, and we will be very happy to have you here. Thank you and goodbye. Take care.